Hello everyone, our topic today is environmental perspective of residential areas. My name is Uyen.
My name is Anjali Muppidi.
My name is Jocie Anderson.
And I'm Henry Parks.
Our goal today is to educate and create awareness about various environmental perspective of residential areas. The four dimensions we're going to cover today is land use, environment, and energy use, and sustainable implementation, and environmental justice.
Okay, so when we're thinking about residential areas, we want to think of some different definitions and how we can define residential areas. So a textbook definition for a residential area is going to be land use in which housing predominates as opposed to industrial and commercial areas. That's a pretty industry focused and it makes a lot of sense, but we wanted to redefine a residential area, kind of using the four perspectives that we're going to outline here. So to us, a residential area is land use that fulfills the human need for housing that can be used sustainably to justify the land use costs. So speaking of land use costs, that's going to be our first section. I'm going to talk about land use here. So I wanted to first open with this land use mosaic image here. So for those viewing online, you can take a minute to pause and look at the different types of land and their proximity to each other. Look for some special features and things that might interest you. We'll come back to this land use mosaic later, and we will proceed here. So firstly, to talk about land use, we're going to talk about residential land use in the United States, because that's kind of the focus of our presentation. According to this graphic here, this is a graphic of the United States where each individual box is going to represent 250,000 acres of land. And then the color is going to correspond to those primary uses on the top. So with that in mind, let's get a size of scale, because this is a really reduced diagram and it's not going to show an accurate accounting of how big these sizes are. So in terms of acreage, the lawn out in front of Kaufman Union, from a rough Google Maps estimate, is about 0.37 to 0.4 acres. So about between 2 and 3 of these is going to equal an acre. So if you can visualize that, that's times over 100 million acres for residential land use. That's going to be the sizes of land that we're dealing with. So this is a pretty large scale. So thinking about land use, you want to think about the opportunity cost. Opportunity cost is something that exists for a lot of different resources, for money, for natural resources, and for lots of other things. So land is no different. And when you think about land use, you have to realize that when you use land for one thing, it can't be used for others. So we could use an acre of land to produce 350 megawatt hours of energy via solar panels. However, we could also use an acre to house 20 to 30 people. So when we think about the decision-making and opportunity cost of land use, we have to make lots of compromises. We have to decide what's more important, what's less important in a given scenario. And we also have to foster innovation to think about how we can combine resources and combine land use to achieve multiple purposes. So one of the things that we can also think about are ecosystems. A lot of people don't really realize it, but ecosystems provide a lot of useful services and necessary services for human beings. One of those is CO2 sequestration, as well as water and other natural resources. And natural resources can be anything from soil we plant our plants in, lumber that we build our homes with, and the food that we eat. But residential areas alter ecosystems. So one of the ways they do that is by changing food web compositions. So they do that by changing habitat, by changing the types of animals that live in areas, the types of plants that grow, and they alternate and they alter the food web compositions by that method. Additionally, fragmentation of land can come when a piece of human technology or human innovation breaks up an ecosystem. So for example, a large pasture ecosystem can be broken up by a single farmstead, and that single farmstead, although small in size, can have a large effect on the ecosystem. And we also want to think about tragedy of the commons, which is where the amount of land that we use for a purpose is that much less land that's available to others. So thinking about urban housing, there's two major types that we will run into, especially in the Minneapolis area. So apartments are going to use less land and they're less expensive for tenants, but they're generally built in developed areas. However, the cons are that they're damaging in construction and they're also expensive in construction. And then the quality of life for tenants is relatively limited. And this also brings up environmental justice concerns for accessibility to housing in different neighborhoods. The other option are single family homes and townhouses. Some of the pros there include more space for families and tenants, and generally a higher quality of life because of that. And the construction to make these is generally less damaging per site. But some of the cons are that these are more expensive to build, or more expensive to own. Construction usually breaks new ground, and because of that, there's more land used up in total for these types of homes. So both of these residences have benefits and costs, and we have to weigh those and think about, again, that opportunity cost idea. So the big question here is, considering all the dimensions I've laid out beforehand, is how can we use land effectively? Well, there's a bunch of approaches that we can take. One of the ways we can use land effectively is through that land use mosaic that I showed earlier, where we have lots of different types of land that can provide those different ecosystem services. When we have those different types of land all close together, it makes it accessible to the people that live nearby, and also makes the interactions between those types of land more prevalent. And we can also foster innovation for multiple use areas, which are going to be things where we have land that is completing multiple types of services. So for example, an agricultural field could also sequestrate more carbon with a cover crop. So some ways we can manage this is through this land use hierarchy model. This is what's on the right here. We can look at the top bar here and think about what sector are we working in. And the second chunk here is what specific goals can we look at through that area. And then through these goals, we can assess what areas are we affecting through our decisions. We can also think of our opportunity cost model of what are we taking out of the environment and what are we preserving. We can never have an equal distribution. We can never have a perfect decision. So we always need to think about what's more important in a given scenario. And we also want to think about intensification of existing systems. So we can think about our systems and how we can improve them rather than breaking new ground. So I'll pass this off to Jocie to talk a little bit more about energy use.
So another dimension to consider within the housing sector is energy use. Energy use is important to study because it can vary between and within regions of the country. Further, the housing sector in the past has been relatively unwilling to adapt to new technologies. However, now they're embracing sustainable technologies and energy efficiency. In 2015, the top 4 energy uses in the US were air conditioning, space heating, water heating, and lighting. It's first important to acknowledge where energy is used the most in order to discover where energy use can be improved. We are in the midst of what some people may call an energy crisis. The war between Russia and Ukraine has caused gas prices to rise. The first energy crisis was in 1973. Similar to the Russian and Ukraine war, the Arab-Israeli conflict was a fight over land. In 1973, an oil embargo was placed on the US, and this caused the price per barrel of oil to skyrocket. The scarcity of resources caused people to demand solar and other renewable energies at a higher rate because after the initial purchase, these resources are basically endlessly free. Just like any other energy source, renewable energies have many pros and cons. I'm going to identify several types of sustainable technologies and discuss the pros and cons. So rooftop solar panels are some of the oldest sustainable technologies around, and they're some of the most widely used. Some pros of these technologies are their long-term return on investment, and they offer the opportunity to be energy independent and live off the grid, which is appealing to many people. Further, there are many financial assistance programs, either through the federal government or through community programs, which allow homeowners to overcome the high initial costs. However, a con of this technology is still the high initial costs, and they are weather dependent on solar availability. Solar water heating is a sustainable alternative to traditional water heating. Pros of this technology include a long-term return on investment and their relatively low maintenance. Cons of this technology include the high initial cost, and they are weather dependent on solar availability. Geothermal energy uses energy from the earth to heat and cool homes. Pros of this technology include that you can use them during the winter and the summer. They're also eco-friendly, and they also can provide a long-term return on investment. However, they are quite site-specific and not appropriate for all sites. For example, a site that's more prone to earthquakes is probably not the best site for a geothermal system. And lastly, passive solar is designed to shade homes from the summer sun while letting in the winter sun. And these systems are relatively affordable, and they don't require direct sunlight. However, because each system is unique and built to the specific home, that can increase the costs. And in addition to implementing sustainable technologies, there are also many certifications that homes can be eligible for. And these certifications represent a commitment to sustainability and energy conservation. And these certifications, I picked out a few that I thought were very prevalent. They include the LEED certification, which stands for Leadership in Environmental and Energy Design. Also the Green Globe certification, and the Energy Star certification, which is based off of the EPA's building rating certificate or rating system. And these technologies and certifications are a great opportunity to increase the overall sustainability of the housing sector.
All right, so now we'll move on to talk about sustainable implementation. The three area that we can use to implement sustainability in housing development are effective land use, site improvement, and use of materials. So choosing site is important to sustainable housing development. One suggestion is to build housing close to daily need infrastructure. Some of the daily need infrastructure is including cities, town, public transportation, grocery, or school. The selecting sites that are close to existing daily needs infrastructure is cost effective and environmental friendly. It would have to maximize the use of the existing infrastructure, promote cycling, walking, and taking public transportation instead of using a personal vehicle. For example, having housing close to everything, you could save a lot of time and money by just traveling to a short distance. We can also build on greenfield, brownfield, or adapted reuse sites. Those fields are outdated, failing, or contaminated sites. But if we can redevelop them, we can have to avoid damage or the loss of the ecosystem, and also protecting the natural resources there. So how do we improve the site of housing? Three recommendations that I want to show you is, first, landscaping should allow water to absorb from rainfall. It helps to reduce runoff water and erosions. And second, the landscape should divert runoff water into retention pond. The pictures here in the right show a symbol of the retention pond. The retention pond are ponds that we use to store water. You can find a lot of them around the University of Minnesota Twin City campus. Those ponds are used to avoid flooding. We also can use them to treat the stored water. Planting trees is also a solution. Trees have to absorb carbon dioxide emission, and they also have to promote shadings and reduce the heat island effect. So there's three strategies that we can use to effectively measurement materials are reduce, reuse, and recycle. To reduce recycle, to reduce the use of materials, we can choose to product that eliminate waste and energy loss of the project. For example, use local materials or engineer framing materials. For reuse, wood steel can be reused, so make sure to use it to reduce them, to saving trees and resources. If the products can be reused, recycle is another option. You can purchase manufacturing recycled materials and to save the environment. Next, I'm going to pass off to Anjali to talk about environmental justice.
So while we've been considering land use, energy use, and how we're going to implement sustainable housing, we need to consider the equity of housing first. So to begin, we're going to define environmental justice. And this is defined as disproportionate suffering of environmental issues by minority and low-income communities. So what does equitable housing look like? Currently, in cities across the United States, and specifically here in Minnesota, Minneapolis, we can see that current residential housing is incredibly harmful towards minority and low-income groups. For example, near the Hennepin Energy Recovery Center, we have northwestern Minneapolis neighborhoods that are situated right next to the HERC. And the HERC converts waste into energy, which actually provides electricity for a lot of people in the city, but the amount of harmful byproducts that are released into the air with the burning of the waste results in about 90% of the people there to be more prone to asthma, as shown by studies done on residential areas by the HERC. So as we can see, housing here is not very equitable. And this is very true, especially due to redlining. Now, Minneapolis and St. Paul have a really strong history of redlining, which is defined as racial discrimination of any kind in housing, but specifically towards Black residents where Black residents live, according to the New York Times. So for example, Interstate 94 tore through the largest African-American community in the Twin Cities, and some statistics show us that this displaced about 1/7 of all the Black people who lived in St. Paul. So if we look at this graphic here, we can see that right around Dayton's Bluff, there's a small bump in Interstate 94 that goes up and then weaves back down. That area specifically manages to avoid white neighborhoods and goes directly into more African-American and Black neighborhoods, as well as low-income and minority areas as well. So Interstate 94 was purposely guided alongside white neighborhoods, but not through white neighborhoods, in order to protect dignity. Another example of redlining would be 35W. So in this case, we can see that the blue areas on this map are still desirable, whereas the yellow and red areas are considered more hazardous or dangerous. As we can see, as 35W makes its way up towards 38th Street, it cuts away from the still desirable areas, which are coincidentally white neighborhoods, and moves more towards the hazardous or declining neighborhoods, and does the same all the way through the north side of the map. Basically, what this shows us is that the amount of redlining done in the Twin Cities is extremely harmful, and the only way that we can really change any of this is to reform housing in the United States. So when we're talking about access to sustainable housing, as Jocie and Uyen mentioned earlier, we know that there are a lot of ways that we can implement sustainable housing into the system. However, most of these are only affordable if you have money. So cool roofs, roof gardens, rain gardens, all of these can be implemented into cities, but only in the higher income areas. Mainly because homeowners are usually expected to pay the cost for these technologies. So is it possible to expand these policies to low-income areas? The answer is maybe, because first we would need government subsidies to first prioritize the cost of these technologies. We would need local government support and grassroots organizations to push for the subsidies to even happen. And all in all, environmental justice is incredibly important to consider when talking about residential areas. So when we consider a summary of all of the ideas here, Henry touched on land use and choice of residential areas, which is incredibly important decision and sacrifice that we need to make so that we can determine the amount of environmental impacts that we are having on the earth. Jocie touched on sustainable technologies that are available within the residential sector that can help, again, overall reduce and improve our environmental impact on the residential sector. Uyen touched on sustainable implementation to housing development by touching on site location, material use, and site improvement. And I touched on residential development only being able to implement sustainability if racial discrimination is first reduced.
So what does this mean for residential areas? We believe that residential areas are vitally important to human well-being, so proper care and purposeful decision-making are essential to implementing sustainability in the housing sector.